Okay, so I'm guessing you guys have already a repo already done in your GitHub site. Have you done that? If you haven't, you go to your GitHub account, and I haven't signed in here, but if you signed in, then on this repository menu, or even I think in the main dashboard, you should see a green button on the right which says new. Click that and give a name, whatever you want, right? CMOS, VLSI lab, or whatever you want to give. And once you have the repo, then let me know. Actually, first, let me see. So how many of you don't, let me clear the, yeah, how many of you need to create the repo? Just raise your hand. Okay, so did you understand how to create it? You go to your, I had asked you to create the repo and come, because without the repository, you can't do anything. Just with the account, you can't do anything. So you need to go to your GitHub site. And like I said, there will be a green button on the right. You click that and create a repo. So let me do this. Let me start the lab. Those who want that GitHub thing, create the repo. Once you're done, let me know, and then we can do that. Okay, I'll just wait for the rest of the people, or maybe a few minutes. So in the meantime, let's create a, let me increase this. Okay, looks like almost everyone is done. I'll just wait for a few minutes. In the meantime, let's go create a directory. Let's call it Lab9, in your workspace, wherever you have it. And then go into that directory. Okay, and from one of the terminals, you can just type SUE2. And you can type SUE2 ampersand. So that way it'll put it in the background. So that way you can still use the terminal. Okay. And if you have a small screen like mine, you might want to resize this. Okay. And in the doc folder, the one which says NGSPICE within CPP's primer actually has a pretty good tutorial on the in the beginning on the SUE2 as well. It kind of explains the library and how to instantiate and so on. And at the very end, all the simulation part, you just ignore it. We are not using CPP sim, so we'll not be using that, but at least the schematic part. And then towards the very end, you'll see there is a chapter also, just how to create cells and all that. And in the doc directory, CPP shared home doc, there is also a SUE2 manual, which I thought I had put it in the menu, but I can put it later on. So you can take a look into the document. So what I'm going to do now is we'll just create a small schematic, and basically we'll create an inverter schematic, and we'll export it as a subcircuit, and we'll write a test bench and instantiate this subcircuit. So for example, whenever, when you're doing the EDA playground, you remember you had your sort of your dot, and then you had your test bench. So you had your test bench, and let's say you designed a counter or whatever, you design a counter, and this is your test bench, right? Test bench, and you basically gave your 1 second. So you gave your clock sources and all that over here, and whatever measure statement. So we'll kind of do it in the similar fashion. So uh, we'll create a test bench, and the schematic we are going to draw using SUE2, we are going to instantiate it, right? We're going to instantiate it as a block with input and output, so in and out, and then write SPICE commands just like we did before, right? So v in, out, DC, 0, and so on. And all the mass and everything will be inside this. So that way what it does, it allows you to change everything in the schematic, export it, and you don't have to change anything in the netlist. The only your commands you're simulating. Now, even this, you can do it in SPICE, but avoid doing that now. That is when you start doing a little bit more simulation, because this is a good practice, and it allows you to use any SPICE function. If you use the schematic, there is only few of the blocks like the voltage source, current source, and so on. Whereas if you use this, then you pretty much use the entire NGSPICE command. Okay, so basically, and this is how you're going to do it in the industry as well if you go, because whatever chip you're designing, so this is your chip, right? There should not be anything other than the transistor, resistors, capacitors, and all that which are available for that technology, right? So when you're going to fabricate, you're going to send this for fabrication, and everything else, this ideal stuff is only for testing. So when you get back your chip, you're basically going to get back this chip, right? And you test it the way you tested it on your test bench by applying oscilloscope, waveform generator, and viewing the signal and so on, right? So you do this. So it's the same sort of the principle. Like whatever you want to fabricate or you want to design, keep it in a separate symbol, and you just use the test bench and instantiate that. Don't put like ideal sources and resistors and all that in your core design that you want to avoid. Okay. And then we won't do that today, but you can look in the schematic, and once you do the circuit, you can actually um, uh, just 1 second. You can create a symbol for it and then instantiate that symbol in another schematic and so on. So basically you can create a hierarchy of levels as much as you want. Okay. All right. So before you start, you have to open one at least. And there is a bug in this particular Linux distribution, LXLD. If you just click, left click, you'll see that nothing comes up. What you have to do is you have to press shift, hold shift down, and then left click on one of these. Like for example, I clicked this one. Okay. So if you click that, you'll see if there is, so these are actually different libraries. You can see this is, I called it my library, and you can select which library you want to be displayed. So in SUE2, this is called the schematic library. The second one is called icon1 and icon2. So you cannot instantiate anything from here. You can only instantiate from these two libraries here. So, and you can select which libraries. So there are different libraries here already. I have removed some of the CPP ones, but you won't need anything more for, for doing any of the SPICE stuff, basically. Okay, so what we're going to do is once you have selected it, then you go to File and you send New Schematic. And here you go to the new library, which new directory you just created. So in my case, I'll go to Om Saroj Lab9, and there is another bug. There's a lot of bugs here. Another bug here. Don't choose this SUE file. Choose all files, and then give a name here. Oh, I'm sorry, mistake. Just let me take it back. Cancel this. I was showing you netlist. Sorry, my fault. Go back to new schematic. I think you can save it there, but just keep it. So you see it's automatically in my lib, because if you store it somewhere else, then you have to create a library, add it and all that. We want to store it in my library, which by default it comes up because it knows that this is the schematic window. So you don't have to change anything here. Don't do that anything here. And I believe here you don't have to select all files. Just keep it as it is and name the file. So name something. So let's call it uh, lab9 underscore inv inverter. Okay, and hit save. Okay, and you saw that you see this lab9 in. Oh yeah, so if you don't, okay, that was the. So if you don't choose all, then it actually gives a underscore SUE on it, and that's why you have to select all files. So you know, if I go file new schematic again, you actually choose all here and give a name, and then it won't give you that underscore SUE. But just that's a bug again. But just forget it. So let it be lab9 underscore in underscore SUE. So now this is your blank sort of canvas, and we're just going to do a inverter. For the inverter, we are going to get NMOS, PMOS, wire it, add the VDD, add a ground, input, output, and that's it. We're done, and we are going to export it to a subdirectory. But I'll just wait here. Just let me know if everyone has the SUE2 open and they're able to, um, get this schematic window and create a new schematic and all that.
Sir, when I'm like clicking that INVX1, I'm not getting anything.
Sorry, I can't hear you, Sumant.
When I am getting clicking on that INVX1, I'm not getting anything.
Shift, left click.
Yes, sir, I'm doing that.
So,
Yes.
sir, then we should go with all files or SUE files.
You can do either. I'm just saying that if you do SUE, then it'll keep giving an underscore SUE
Yeah.
name to it. And so if you want to avoid that, just go all.
Okay.
Okay. So Sumant, are you able to do see the InvX1 now or not? You can click any schematic. The thing is that if you don't use the library manager, you have to open a schematic first to create the thing.
Uh, we can uh, we can use any schema like in my
Yeah.
library or space or anything we can use, right?
No, my library only. That is the schematic window. Don't click the other ones. Just click my library. The other ones is for you to get the components from there and place it. Okay. So everyone just so let me start all over again. So if somebody still falling back, uh, so file, I'm going to exit. Okay. So type SUE2 ampersand. So that way it'll move it to the background and you can still use the terminal. Okay. And then resize if you need to. And this is your schematic library. So all your schematic has to be done. So I already have created a lab in SUE2, but I'll create another one. Let's say I create new schematic. Okay, you can see it's giving me error because I need to select something first. So you can choose any one of these. So you probably have only InvX1 and HSPC. So hold shift and left click and you'll see a schematic pop up. There is another way to create the schematic. You can go to the library manager, but don't do that now. You can follow the manual and do that. We'll just do a quick one just the way I'm showing you. So once you have any schematic open, don't select anything from these SPICE and devices here. Then you can go file, new schematic, And then here, like I said, files of type, if you keep this SUE, then it is going to add an underscore SUE, which is, I think, a bug. So you can select all files. And here I'm going to give the same name again, Lab9 INV, and hit save. So you can see now there is no underscore here. And so this is your window. You can see on the top here, it says Lab9 underscore ENV. So you have this blank slate now. Is everyone, does everyone have the window open, or raise your hand if you still want me to wait few more minutes? Okay, good. So now what we're going to do is, like I said, we're going to get NMOS, PMOS, and VDD, ground, input, output, wire them up, and that's it. We're just going to create the inverter. So in the SPICE library, if you go down, you'll see that I've added this SCMOS N and SCMOS P's. So we are going to use the four in the 4 terminal. So basically, you'll also connect bulk. There are 3 terminal devices, but don't connect 3 terminal devices. So the SCMOS N4 and SCMOS P4, these are the 2 devices we're going to get. And again, same thing, just left click won't work. And that's a problem only in this particular Linux distribution, that is the LXLE. If you're using Ubuntu or anything like that, or in your Windows, it will not be a problem. So again, hold shift. And this is something I have written, that 5 steps I have written on the GitHub. It is there, but obviously nobody has read it. So hold shift, left click, and then you can release the mouse button and release the shift. And you can see now you, what is this? NMOS. I have the NMOS here. Okay. So wherever you want to place it, you can hold it there and hit left button, and you can click the left button. And then click somewhere else, and you'll see that, it's placed. Okay. So this is the NMOS, and to change the properties, you can see the W is 0.6, L is 0.4. And to change the properties of this, you can double click on top of it, and you can see the cell is called SCMOS N4, and the name we're going to give M1. The rest, everything, we'll just leave it as it is. We're just going to use as it is. Okay. So that's our NMOS. Now we're going to get a PMOS. So we're going to get SCMOS P4. Same thing again, shift, left click, and then you can release button and place it on top here. Okay. And click somewhere else, and then you should see it turned this green and this color. Again, click on this. We'll leave the W, L, and M to be the same. We'll just name it as M2. Hit done. So we have the 2 transistors we need. Okay. Now from these devices, we're going to get a global symbol. Okay. So first we're going to get VDD. Actually, for both VDD and ground, it is the same one. Is the same one. So again, same thing, shift, left click, and then you'll get this global. So it's upside down. So I'll first do the ground. So put it somewhere close to the source end, hit click. And if you click somewhere else, then you'll see it is placed. Go again, shift, left click, and then I want to turn it upside down here. You can rotate it by placing, while you are moving it, you can press R. So hit R twice, like rotate, and then place it again. Okay. And all we need now is to wire it and put the input output port. So let's wire it first. Okay, everyone okay till here, or somebody stuck somewhere? and keep saving it as you're doing. There's an unnamed pin. That's fine. You just hit OK. Yeah, so I had to name this. So what I'm going to do is I'm going to double click this. This is just a unnamed global pin. I'll call this VDD. And I'll click this and call this ground. This is actually not a preferred method in industry. We never do global except for standard cells. In analog, we always put pins here, but for this exercise, we'll just show it to you. Okay.
Sir, how to undo here?
How to undo?
Yes, sir.
Edit, undo, U.
Okay, sir.
Okay, so you can use the menu button as well. And you can see on the right here, there is a M on the right hand side that basically tells you that it has been modified and not saved. So that way, you have to save it whenever. So you can see once I save it, that M sign is gone. Okay, so now we are going to wire it up. For wiring, you can go to edit and add wire. You can do that, or just hit, you can see these are the bind keys or the shortcuts. You can see it's W, and W is pretty much, kind of universal. Any tool you use, Cadence, Mentor Graphics, or whatever you use, most of the time they're W. So which is nice. So hit W, and now you're in the wire mode. And one thing to see is in the SUE2, yeah, so you can see here on the top right over here, always pay attention to it. This tells you which mode you are in. You can see button 1, add segment, button 3, end set, delete backspace, removes the last segment. It tells you everything. Now, if I hit escape, you'll see it's gone. That means I'm not in wire mode. And now if I press W, you'll see it come back on, right? So this is a way to see which mode you are in. So I'm in the wire mode right now. I'm going to start wiring it up. So I'll click first point, click the second point, first point, second point, start, and start, go here, and I'm going to connect the bulbs.
So how to give the name?
Which name on the VDD global? Yeah, escape.
No, sir.
Which name?
SCMOS and SCMOS P.
You don't
M1,
name
M2.
that. You choose it from here. Did you just join?
Yes. No, sir. I could not
Yeah,
save it.
you do left shift, left click on SPICE SCMOS, and here once you do that, you'll see this, and you can place it wherever you want. And again, if you look at on the top here, it says button 1 drops SCMON, hold shift to repeat drops. So if you want to keep repeating it, so you can do this. And sorry, I removed the shift, but um, if you shift left click, and while you are placing it, if you want to place multiple of this, so you can hold the shift key down and just keep placing as many as you want.
How to name it? Metal M1, M2.
Double click it, double click
What is?
and name it here.
Okay.
Okay, so I'll continue the wiring. All right, so I'm wired up. The drains are connected, source are VDD, bulk is VDD, bulk of NMOS is ground, source is ground, inputs are connected. Now, the only thing which is left is to give it an output pins. And that's also in the device library. So you see in, out, input, output, name net. This is where you're going to grab all that, wherever you grab that global. So I'm going to use the input pin. So I'll again shift, hold shift down, left click and drag it, place it, then go to output, shift, hold shift down, left click, and then place it near somewhere here. And we'll first name them. I'll call this in. Let's call it V in. let's call this V out. Okay, and then wire it up.
Sir,
Yeah.
I have added an extra wire by mistake. How to remove that?
You should be able to, so escape, you shouldn't see anything here, and then click and then delete. I think that should work. Yeah.
Yes, sir. Working.
So can you please repeat that how to undo?
Which one? Delete.
How to no how to undo?
Undo is U. Edit, undo, U.
Can we directly from our keyboard we press U and it will work?
Yes. Just try it. Don't be afraid.
Uh, Actually, it didn't work. That's why I asked.
You must be, so that's why I said you keep watching this window here. You must
Yes,
be
sir.
some
Yes, sir. I
wire
watched.
mode or something.
No, sir. I checked
Come
it.
on. You guys are like always like this. So let's say I do a wire. Or let's say I place a device, right? I place it and I hit undo U. Yeah, I think the keyboard is probably mapped to something else. So you might be right. No, it's messing it up. Yeah, just delete it.
Okay.
Yeah, looks like for some. Yeah, this is SUE2 is not the most bug-free software. It's actually a really old software which Mike kind of took it and wrapped around some script around it. But it's nice for IC design because you can create files with write simple tickle script to create these symbols with export netlist and all that very easily compared to anything open source available.
Sir, how to get VDD?
Global. Shift left click, get global, but you have to name it. You have to click, double click, and name it VDD.
Sir, also for ground, we need to choose global.
Yeah, ground needs also to be global. It's just the way we are going to write our test bench. Okay, I'm just going to show you one way to write the test bench where you can use global input, output, and all that. So just mostly for demo purposes. Like I just said, in digital standard cells, you actually the VDD and grounds are almost always global, but when you're doing custom digital or analog design, we never ever do globals here because that's a nightmare to make mistakes and all that. So there, it's usually pins, but for this particular demonstration, let's do global so that way you'll see how the global works in SPICE. And obviously you can do all sorts of zoom and zoom out. If you go to window, you can see Z and capital Z and small z is zoom. F is for fit. So for example, here if I do Z, you can see that's zooming in. Shift is zooming out. Arrow keys for panning. And then if you want to fit it, let's say you're lost somewhere, it's like gone there, you don't know where you are, just hit F, fit, and it'll come back. Okay, everyone done with this, or you're still, just raise your hand if you want me to wait a few more minutes. I don't know why. This shoulder point here, I'm going to just delete it. Oh,
Sir, how to invert the VDD?
R. When you're getting the symbol, just hit R, rotate. You can see it here as well. Okay, let me move on. So Ashwini, while you're catching up, I'll just start showing this guy. So now what we need to do is we are going to create a netlist out of this, right? So you wrote everything by hand before, right? So now we are going to generate it automatically from this window. So that way you don't have to do connections by hand and so on, which is good because when you have complicated circuits, you just can't do it by hand because invariably you're going to make mistakes. So to create a netlist, what you do is you go to tools and you see there are two options here: create SPICE netlist with top sub. Okay. Let me just quickly check this. Give me a second. Yeah, okay, we don't want this. Okay, so we go here in the tools. You'll see there are two options to do create netlist from the schematic. One which just plain says create SPICE netlist. Another says create SPICE netlist with top sub. So top sub in the sense it creates a sub-circuit of this. Now, this, if you had all your voltage source and everything inside the schematic, you would just use this and, you know, basically netlist it out and then go there and add whatever command. But the problem is, like for example, writing a dot measure and all that, you have to create instances for it, write those commands and all that. So that's why it's best you just restrict this to only your circuit, and all your test bench stuff like writing voltage sources, measure statements and all that, you do it in SPICE like you're doing before. So we are going to create a SPICE netlist, and in your Lab9 directory, you browse there. So click here and browse to that directory if you haven't done already. And when you come to this window, deselect this from .spe to all files star. Okay. Otherwise, what it's going to do is just like in schematic, it'll create .sp. It'll create two .sps, which is not I mean, it's not a technical issue, but it's just confusing. Okay, and then hit save. If everything went fine, it'll say SpiceNet listing Lab9 inverter completed with no errors, right? Now you go to your terminal, basically. You open your terminal, and in the Lab9, you should see a circuit called lab9inv.sp, right? If you open this file here, you'll see that it actually took the inverter, and you can see it's connected drain, gate, source, drain, gate, source, W and L, which we specified. It created a subcircuit out of it, and but the thing is that it also added this .end because it is expecting you add commands here, but we are not going to do that. So what you do is you delete this line because we are going to include this in our top test bench. Okay.
Excuse me, sir.
Yes.
So nothing is happening in my SUE2. Like I'm not able to click anything. I'm not able to do anything. Everything stopped. Just I can move the mouse pointer.
Just exit and start all over again. I don't know what you did. You might have gone into do like a couple of command modes. You have to be careful. This is not like your cadence. It's a very buggy free software, so you have to be careful with it. Just exit it and start all over again. Okay, so delete that dot line, and I guess I don't know if you've been in the subcircuit command. So basically this, just like you instantiate the MOS transistor, the subcircuit allows you to do hierarchy. For example, if I want to instantiate 5 of these, I don't have to copy 5 of these now. All I have to do is instantiate this, and I'll show you how to instantiate this later on. But the subcircuit name is basically, you start with dot subcircuit, the name of the subcircuit, that's what we're going to call this with, and the ports. And if you're passing any parameters, the parameters will actually follow here. So if I was passing W and L, which you can do, then they would have followed here. And then once your subcircuit is done, you do dot and S and the subcircuit name. So this is your complete subcircuit. Okay. So we are going to quit this, and we are going to start editing a new file, and we'll name it TB_something, meaning test bench. So that way we know that it is a test bench for this. So you can use the liftpad or Vim, and start a new file called TB_. I'll just call it inv.sp. Okay, so basically then from the file name, I know that this is a test bench for an inverter. So I hit enter. So obviously this is a new file. First line is a title. So I'll say this is test bench. Hit I for insert. This is for VI only. Test bench for inverter sub circuit. Okay. And then now we are going to instantiate the library model file. And if you remember, what is it? .lib/project. I'll show you a trick here. If you're in VI, you hit escape, go into command mode, and then do shift : and type split. Okay, so you type split, and then I'm going to go back to my lab, yesterday's lab 8, and you can hit tab here. You can see there is 2 lab 8 sandbox, and I want to go lab 8, so hit / and again hit tab. You can see all these files, and you can keep hitting tab to browse through all of them. I want to open this VGS ID temp.sp. Okay, and so you can see that um, it is split into 2 files now. Bottom file is what I'm uh, editing. Top file is what I have here. You can copy the top file, hit YY, this line, not top file, but this line. So YY. Okay. To move to this window, you can't use mouse. It doesn't work with Vim. You do Control W. Ah, I knew I was going to do this. Yeah, Control W is closing the window. So don't do Control W. You have to open this keyboard and first Control and then Control WW. You see I came to this file here and then hit P, shut Control off, and then hit P. You see I just copied it from the previous file. And then if you want to go back to that previous file, then hit Control and then hit WW. You go back to the file and you can shut the control off now. And then here you quit this file and that's it. You just copied it from the previous file. But if you're confused with that, don't try it. Just just write it from here for now.
So,
Yep.
so while creating that schematic,
Yep.
actually, I saved it, but right now it is showing there are two files with the same name and one with a .bak.
You must have typed back or something. I don't know what you did. Just don't
Uh,
use that. Just use the one which you want to use. I mean, go
yes, sir.
back here and then do, if you have saved it, then do shift right click to the one you want to use. So for example, you want to use this, save live click, or you want to use this, or you want to use this.
Okay.
Just click that and then regenerate the netlist. So the red.back file you must have by mistake typed it or
And
something.
while generating that netlist, it is coming empty also.
What is coming empty?
That netlist.
Did you generate after you did the schematic?
Yes, sir.
Okay. Did it give you any error?
Yes. Just let me check again.
Okay. What's the error?
So error is error in trim unused modules. Can't find top module lab inverter. Child process exited abnormally.
I have no idea what you did. Just exit, save it,
Okay, sir.
exit, come back again.
Okay.
Yeah, I have no idea what you did. Okay, so I'll go on and maybe what I'll do is in the end, I'll just keep this open. You can copy it. So first, use the library file. And the other way is you copy your old file. You can copy your old file, delete everything, keep the .lib, so that way you don't have to type it again. And either way, so but for now, let's say whoever is there, just type. And when you're typing it by hand, you're always tend to make mistakes, right? And then I'm going to get this, oh, this is not working. I mean, you don't bother to check, so you're just not working. So find out whatever way suits you the best. So copy your old file, delete every other line, just keep that, or whatever way. But just make sure that don't make a lot of errors and then just keep screaming. So the library is not found. This. Okay. All right. So now what we're going to do is we are going to include um, that SPICE file we just generated. Okay. Include the SPICE netlist or inverter netlist. We'll call it inverter netlist. Inverter netlist. And it is and for including SPICE, you can use the command .include, and you can just give the file name. So in my case, what do I have my file name? Lab9 underscore inv underscore sp. Lab9 underscore inv dot sp. So basically that dot include is like taking all the contents of the file and actually pasting it here. But instead of doing that, you just do .include. So that way, and I'll show you. So then what happens is you want to change the device, you just go here, change the device, netlist it to this file, and then you run this. You don't have to do any change to your test bench. You just keep changing your this thing, right? Redo. Okay, so once, so this is including the file, but I need to instantiate the device right now. Okay, and so instantiate inverter, and you do that by starting with the X. First, you start with the X, like with M. For MOS transistor, you start with M. Capacitor, you start with C. Resistor, we start with R. Inductor with L. So for instantiating any device, you start with X, and then you can give any name. So I'll give it inverter 1, let's say. Okay, and then you give the name of that subcircuit, right? And the name of the subcircuit was also Lab9_in. So if you I'll keep it open here. Let me just open the lab. So this is the subcircuit, right? And you can see the name of the subcircuit is Lab9_in. And then the ports are V in and V out. Okay. So I'll keep the name in and then the node names here. Okay. So the node names have to be in the same order here because it's not like your Verilog or anything where you can do associative names. It has to be in the same order. So, but here you can give any name you want. So instead of giving V in, V out, I'll just give in, out. These are the two node names. So I have an inverter now instantiated with in and out. And I can instantiate as many as I want right now. So if I want 4 inverters here, I just name them differently. R2, R3, R4. Okay. And these are all 4 inverters in parallel, connected in parallel. So you can see the power of subcircuit is that, I didn't have to copy 4, 8 devices, start connecting them, make errors and all that. All I did was just instantiate it. It's just like putting a device. It's like IC on your breadboard, right? You just put it on your breadboard. It's just like that. But for now, we'll just keep it 1.
Sir, I think that node name has to be.
Oh, it's right. Right, thanks. So yeah, node name first and then the name of the subcircuit last. Okay, it's the subcircuit definition has the name first, but when you instantiate it, you give it last. And then if you had parameters, you could give the parameters after this. Like let's say you wanted to pass the W and L, you could pass it after this. But we don't have any parameters; all of them are fixed. Okay, so all right. Now, before I start doing it, maybe I'll just define it here. So if you see the ground and VDD, right? They are inside this. Although they were global in the schematic, but in SPICE, there is no way to know that, right? Because it is just an internal symbol for you. We have drawn it that way in this thing, but you see that it's just come as a pin inside subcircuit. So in other words, right now, the VDD and the ground is internal and it's not coming out. If it is not coming out, it's going to be floating, right? So I'm going to make it global. So in SPICE, to make any node global, you type .global and give the node name. So here I'll give VDD and ground. Now VDD is actually a special node name. I mean, it's just a node name, but ground is not. Ground is actually a special name. So ground is by default 0, right? So 0 and ground are actually the same. So when you name something ground in SPICE, it actually automatically becomes 0. So you have to be careful. So that's why I actually don't like using it that way, but just like I said, for demo purpose. So now I'll start. So I'm instantiated the VDD and grounds are global right now. The ground is automatically connected to 0. I don't have to do anything. I have to connect the VDD in and out, right? Out is obviously the output, but input and output, right? So let's connect our sources. So for sources, I'll say supply voltage, I'll name it as V supply, let's say. And the node name is VDD. And this is a global name. So global in the sense that wherever there is VDD nodes, doesn't matter which subcircuit, which hierarchy, they will be connected to V supply. Okay. And then 0 to DC value of, let's say, 5 volts. So this is my supply voltage. And then for input, V in, I'm going to use, so it's going to be the input node to ground, and I'm going to use a special voltage source called pulse. Okay. And pulse, let me see what the,
Initial voltage, final voltage.
yeah, initial, final,
Yeah.
delay, TRF, TF, pulse width, period. And if you leave anything, by default, it will become 0. So initial voltage is 0. Final voltage is, okay, here I'm going to show you another command here. So you can use a command in SPICE called .param, and we are going to say V supply, let's say. What is parameter thing I have? Equals to, so V supply equals to, and we'll give 5 volts here. I'll make it 5.0. And then this one in the DC supply, I'll make it V supply. And then here I'll make it V supply. And the delay, I'll keep it 0. TR, I'll keep it 1 nanosecond, 1 nanosecond. Pulse width, I'll keep it, no, not 1 nanosecond is too much. 10 picosecond, 10 picosecond, 100 picosecond. Pulse width, 200 picosecond. Period. That's it allowed. So the reason I did this, for example, is wherever anything is supply dependent, I'll use this parameter called supply. So the advantage of that is if I want to simulate it 5 volt, I just change it here. If I want to change it, simulate it for 3.3 volts, then everything where supply oriented, they automatically change to 3.3 volts. So this is a good way to parameterize it. Okay. And then I'm just going to add a load capacitance. So output to 0, let's say 50 femtofarad. 50F should do it. All right. So all my sources and everything is set. Now I'm going to do analysis. I'll do a .tran, and .tran is the step size. So I'll simulate it for, let's say 300 picosecond, step size of, let's say 1 picosecond. Okay. So 1 pico, just give me a second. Okay, sorry, I'm back. All right, so we want to do a transient analysis. So 1 picosecond step size, 300 picosecond end time, and then dot control, run it, and we'll just plot the output first and see before we do anything. And the control and the spice, and hopefully this is good enough. So let's run this. Something is not right.
Very high.
Where is it just slow?
Yes,
50 femto should be okay. Okay, let me first increase this and see.
yes.
So I'll make it 1 nano or 10 nano. Let's make it 100 nano. 200 nano. Okay, yeah, I think this is 0.5 technology. It's not that fast. Okay, 5 nanosecond. Let me just change this. So make it 10, 20. Okay, so I have a rise for. Okay, so how's everyone doing? Able to let me keep this window open. Any of you done the test bench yet or working on it?
No, sir.
Okay, while you're working on it, let me do this.
Sir, how did you get that Lab9 Inverter.sp file on the SUE2 list?
Tools, SPICE netlist with top sub. You want to use this one. Okay. And like I said, when you do this, select all files so that way it doesn't do .sp, and then hit save. Okay. While you're okay, this is the test bench. You can look at this and copy. So while you're doing this, what I'll do is, let me do this. Okay, so I just put the test bench on the GitHub page. So what you guys can do now is, so that we expedite it, let this be open here.
Excuse me, sir.
Yes.
I'm getting an error which is saying that dot include lab9 is not possible. Like could not find the include file lab9.
So Sumant, I mean, how long it will take you to debug this on your own? Obviously you've made a mistake, right? Why don't you just figure it out?
Sir, in the code I have written that dot include lab9.
I mean, you are talking like a 6-year-old. I mean, I know 6-year-olds which are, you do this again and again, and I'm getting frustrated. Obviously, I have demonstrated like 3,000 times, right? And this is a SPICE command. I just demonstrated and showed it to you. So you made a mistake. Either you don't have the file in that directory, you have made a mistake. Just figure it out, right? In the last 4 weeks, every time you do that, it's a mistake you have done, obviously, because I have told you 3,000 times, these tools are not, they're agnostic to who you are. They don't care you're Sumant or, somebody else, right? So I don't know what mistake you've done. I can't see it. So just figure it out, right? So from the error, it's clear that either you don't have the file there, you're given a file name wrong. Don't keep saying that I have given the file name wrong, right? I mean, I've given the file name. Obviously, you've given it wrong. Either written it wrong or you don't have it. Just figure it out. How hard it is. I mean, we've been doing this for the last 3 weeks now. Still can't figure it out. Send a snapshot, but just
I'm trying again.
yeah, try it. Please try. We're not here to debug because you're busy curing cancer or something. I don't know what you're doing. So, okay. So for those of you still struggling, go to SI, the repository, and do a git space pull. Okay. And there should be a labs lab9 directory with the test bench code, which I just wrote here. It's there. Okay. And then what you do is you go back to your working directory. And if you have it written TB_inv, maybe change it to some other name so that you don't overwrite it. And then do just like before, CP. For some of you, tilde is not working. So just do $home, capital home, /SI, all that, CMOS VLSI, labs, lab9, TB_inv.sp, and then space dot. You want the same file name, so give it dot, and you should have that same file which I have in your directory now. Okay. So can everyone, so if you're working on your own, you haven't got it completed, I would say just rename to some other file and copy this, so that way we can proceed. And let me know when you have it and you're able to run it. So who is not yet, who's not able to create the netlist yet? What's the problems with this?
So maybe some wire is remaining
What's the error? Same error?
yes sir, same error.
Can you send a
Untrim.
screenshot of it?
Okay sir.
Who else is stuck with the netlist? So everyone is able to netlist except for Swades right now. Just raise your hand if you're not able to netlist. So Swades, did you send your snapshot?
So just wait.
So I am unable to do the netlist.
What's your problem?
So after the schematic, I'll not follow the step.
So have you done the schematic already?
Yes, sir.
Okay. So when you go netlist, create SPICE netlist with top sub, and go to your lab folder, wherever your lab folder is, browse and go there. And then, like I said, files of type, click all files and give a name and hit space. What's happening?
Yes, sir. After that, what I have to do?
So did it netlist or not?
Yes, sir.
Okay. What was the
I saved
problem?
it. I saved it, and how to get that spice code
I just told you.
in the VI editor.
First, go. Did you do a git pull?
No,
Yeah. So you need to go to the repository to that SI3031 and do a git pull so that you'll get the test bench, and then copy that test bench into your directory. So let me show again. So you go to, first go to your home directory, and if you do ls, you'll see this SI 2021, right? You go here, you'll see a labs folder. Oh, actually stay here. Those who haven't, do a git space pull. Okay. If you do that, you should see a labs9 folder now under the labs folder. So if I do ls labs, you'll see lab9. In that, there is a code, the test bench code. And then you go back to your working directory, wherever you are working. In my case, it is lab9 in my home directory. And here you do cp $home /si 2021 blah blah labs lab9 tb space dot, right? I already have the file, so I'm not going to do that now. So once you do that, you should see a file called tb_inv.sp, and you can open that in VI or LeafPad, whichever you're comfortable with, and you should see this code, what I have here.
okay, sir. Thank you.
Who else? Who else is having issues?
So I have sent it.
What is your schematic name?
So inverted then you.
But I don't see it on the right hand side. Where have you created this? It's not in my lib.
Yes, it
Yes,
is not.
sir. I am creating that on my own directory.
Why?
I told you not to do that because there's a whole library process manager. I said you have to do it in my lib.
Hmm.
You can't do that.
So that's why it is creating.
Yes, it is creating, because that's why. You have to create it in my lib.
Okay.
Just follow like what I'm saying. Once you have it working, do whatever you want to do. But at least just follow what I'm saying right now.
Yes, I will finish.
Okay, how many of you are able to simulate and run it right now? Any of you? Raise your hand. Okay, good. Okay, so and how many of you are stuck halfway? Just raise your hand. Like, okay, for people who are stuck halfway, I would suggest just copy this. Okay, so that you can proceed. Copy this and then we'll keep going. Okay. All right. So while you're doing that copying and all that stuff, let me just add some measure statement here. So I'll just use the guys you've used before. And something set some. So dot measure tran, and then this is the name, right? TP LH. And so we are going to do low to high. So V of in val equals to 0.5 into V supply, fall equals to 1, target V of out, V of out, val equals to VD by 2, rise equals to 1. So we're doing what? That measure not found. Oh, actually it's not. It should be spice.
No, sir, not that.
Say that again.
That is trigger, TRIG. Instead of TPHL, that is trig. Dot measure tran, then trig. Trigger point.
Yeah, no, TPHL is fine. That's the name. Yeah, I forgot the trick. No, actually the dot measure cannot be inside the control. That's what it was complaining.
Oh.
Yeah, that's true. I need the trig. Let's do source. So TPLH it's showing as 0.13, so 113 picosecond, right? Let's measure it and see. Low to high. Oh, I deleted the. So low to high. Oh, actually, I don't have the V in. Let me just plot the V in as well. So 50% is here. See, DX is 237. It's showing 113. Oh, sorry, low to high. I'm doing the other one. So it should be the other one. Oh, this is even more. Yeah, this is 560. So triggering at 15.13 nanosecond. Here it is 15.01 and targeting at 15.1. Sorry, triggering at 15.01, targeting at 15.13. Here it is 15.01 and 15. Oh, sorry, I should see this one here. So, oh no, this one here, 15.01 and 15.58. So yeah, 500. So, but this one is triggering at 15.13. Let me just use the values here. So we'll do 2.5. Oh, 550. Yeah, for some, I think might be to do with the expression. Maybe I have to close it in quotes or something. I'll try quotes. Yeah, I think it's quotes. 552 picosecond is calculated. And if I measure here, it's 2.5. The X is 573. Yeah, that's just the error of my cursor. Okay, and I'm going to add that other one. YYP. So I'll do TP HL. Vin is, and now Vin is going to be rise. And this is going to be fall. So this should be, okay, so measured is 221 picosecond. This is 220, which is close. Okay. All right, so how's everyone doing? Ashwin, so this you're able to finish or not?
So,
Yes.
so after that git pull, what we have to write that it won't override the data. Just append, just to append what we have to write.
Append what? To append what to what? I didn't
Uh,
get it.
Sir, you told that just to git pull that.
Yeah. Did you do
So
it?
it is showing that it will override the data. So
Yeah. So you are actually working in the Git repository. Who I asked you not to work there. Well, just overwrite it. Why are you working on the Git repo?
no, sir, I'm just pulling it.
Yes, you're pulling it, but you have been working there. Otherwise, why would it say that it's trying to overroot it?
No, sir, I just go to that SI2021 that
I
directory.
understand. So this, you're not listening to me. So if you had not worked there, you would not have made any changes. If you would not have made any changes, if you just did a Git pull, it would just take the new stuff and put it there. You got it?
Okay,
What you have
so
done is you have worked there in the Git repo, which I asked you from day one. Do not work in the repository. Okay, for this same reason. So you have worked there, you have modified something. Now it's saying to overwrite it, just say yes and go ahead, overwrite it unless you want to copy that before.
okay.
Okay. Got it or not?
So one doubt,
Yes.
in which directory I have to do that git pull?
SI 2021, you just said, right? You wherever you did it before. I don't know where you did it before. So everyone did it in their home directory.
Yes, sir.
So
Home
if you go
directory.
into their home directory, do you have a file called SI 2021-03 CMOS VLSI?
Yes, sir. Yes, sir.
Just go into that and do a git pull.
Yes, sir. I did that.
Okay. What is happening?
So it's showing that your local changes to the following files would be overwritten by merge.
That's what I say. Why did you work there? I asked
I
you
never,
not to work in that directory.
I never worked there.
See, again, you guys are like, I mean, in that repo, if you never worked, you will never get that error. So by mistake, you've done it. That's fine. But don't say that I never worked there, right? You've changed a file. The file it is complaining about, you've changed it. Otherwise, you'll never get that error. Which file is it complaining about? Just tell me.
It's not showing any that type of.
Just overwrite it. If you're saying that you don't know what you've written it. Now, the thing is that, okay, I have to tell you that the schematic is written over there. So if you actually wrote a schematic of the same name, then in that file, which you should not have, then maybe it is saying that it is going to overwrite it. So just check which file it is. It should not be the SUE2 file. Which file is it saying it will overwrite it?
Thus, it's showing that updating A6828E1.
I don't know what that is.
Shell dot cpp sim view, that one.
Yeah. So those are all the CPP sims. So because I don't know, you might have changed something in the local directory or something.
Okay,
Just
actually I did one mistake, that I was working in that SUE2 like in other tab, and by opening another tab, I just wanted to, I committed this thing.
I don't know what you just said, but yeah, if you want that file, copy it somewhere, just say overwrite and be done with it. Okay.
Okay.
All right. For the rest of the people, I'll just go ahead and, so hope everyone is at least following it, even people who haven't added. So you can see that whatever we netlisted out, it was, we instantiated this as an inverter, right? So you can see, so I'll show you just one example. So we calculated the TP LH, low to high to be 552 picosecond, high to low 219, which makes sense because we have the same size PMOS and same size NMOS. So the high to low is going to be faster than low to high. Okay, so that's what you see, 552 picosecond for low to high, and high to low is 219, almost double. Okay, so as I was saying, I have instantiated this inverter, right? I can just instantiate another inverter here, right? But I have to name it obviously something else. I'll just name it 2. So basically 2 inverters in parallel. Essentially, it looks like as if the widths have been doubled, right? So that's essentially what I have done. So if I do this, now I should see my TPLH and TPHL become half. So let's see if that's the case. So yes, 500 plus went to 216, 222 became 114, right? So you see the power of like doing it in Subcircuit is because now you can just instantiate it. Plus, if I want to make that change in the schematic, so I go to the schematic window. All right. Ah. Yeah, it's not the most friendliest tool for sure. Just going to exit it. So I'm going to select my inverter again, shift this, and then I want to double this size. So I'll just double it by making m equals to 2, and I'll make this m equals to 2 too. Forget this. So basically what I'm trying to show here is I'm going to change the size now, netlist it out and just run the test bench. I don't have to do anything in the test bench. Now netlist, I have to make that small change, that .end file, but other than that, I don't have to do anything. So I double the size of the NMOS and PMOS, save it, okay. And I go to, do the netlist now. So netlist top sub, change it to all, I'll go to my lab directory and lab save says completed without error. I think it did overwrite it, doesn't give you a warning. If you go to your lab9, so if I open lab9 in .sp, so you can see now m is equal to 2, but I have to still remove this and I save it. And I don't do anything with the test bench because it's already instantiated, everything is there. I just rerun it. And you should see, yeah, you can see, oops. Thing still has the old one. Yeah, so you can see the delays now became half because I changed the sizes to double. So that's how any circuit now you basically want to create the circuit and not have any of your test bench there. Do a separate test bench so that way you can control, do measures and all that. And anytime you make the change in circuit, you just netlist it out and you're done. Okay. Makes sense. Any questions on this one? Looks like some of you got it done. How about you, Sumant? Did you finally get it done or not?
Sir, doing, sir. Like again, I got disconnected, and the network also is not good here. So I'm trying
Yeah,
again.
if your network is not good, then you're going to have trouble with the keystrokes and all that.
Yes, sir, I'm having that.
Yeah. Okay. So while maybe some of you are doing it, let me do the GitHub thing now. So let's do that now. And then if you have any other questions after that, I can take it. Okay. Those who have created your Git repos, go to your home directory. Okay. Everyone go to your home directory. I'll just wait. And then here you do git clone https github.com and then give the name of your account. So for example, we are using our lab account. It is Silicon VLSI. That is your account name. So if you have given your username or your own name or whatever it is, you give that name. And then after that, the repo name. Like for example, in our case, the repo name was SI 2021-03, blah, blah, blah. So that's the repo name you want to give. So whatever repo name you have here in the GitHub page. So for example, if whatever repo name you have created here. So for example, if I go here, you can see this is what you want to cut and paste in your Git clone. Okay, go to your repo and well, you can't cut and paste. You can, but the clipboard is a little quirky. So just type it in. Okay. So once you do that, whatever is your repo name, you would see a directory here with that name. And I'm not going to do that because I don't have an extra one. So I'll assume that you have one just like this. So if you go in, if you haven't added anything, it should be just blank. Okay. Get till here, and then I'll show you how to add your lab here, and then push it to your GitHub account.
So after the repo name, what we have to do?
Just do git clone your path to your repo in your home directory.
Yes, I,
Git
yes, sir.
clone and give the whole path to your repository.
Yes, I done that.
Okay, what are you asking? Is it cloned now? Do you have the directory?
No, so after the repo name, that is SI 2021-03 Simosville SI.
No. What is your repo? Where are you going to do it? Did you name it SI 2021-03 as well?
No, sir, no, sir. My repo name is different.
Just give your repo name. This is for
Yes, sir, I
backing up, for
given that.
people wanting to back up their stuff into their GitHub page.
Sir, I have given my repo name, then the repository name SI 2021.
Oh,
Whole name.
just your repo name and hit enter.
Okay.
github.com, then your account name, repo name, and hit enter. Obviously, it's saying cloning it won't find, but you should have yours.
Sir, repo name here, yours is lab, right?
No. What is it that you created here in your GitHub page?
Uh,
Your GitHub page, what is this name and what is the repository name?
Sir, I am only getting like https github.com Suman Pulaki VLSI. That complete one I have typed. Sir.
So what's your username in GitHub?
Suman Pulaki.
Okay. And in Suman Pulaki, what is your repository name?
VLSI.
Okay, type that here. Type that here.
Yes, sir. We did that.
You done?
Yes, sir.
Everyone done cloning their own repo, not my SI 2021,
Yes, sir.
your own repo, right? Anyone still doing? Raise your hand.
The username for this github.com, we have to write our name.
No, is it because did you do it as a private repo?
Yes, sir.
Well, then you have to give your username password. Whatever is your GitHub username password.
Okay.
I mean, there's nothing proprietary here. You could have just made it public.
Can I change it to public? Now?
Don't just clone it right now. I don't want you to waste any time right now. Just clone it. Give your username, password, and clone it.
Okay.
Okay, Ashwini, done? Are you done, Ashwini?
So I will do that. Please move ahead.
Okay. All right. So let me go ahead. So like I said, once you're done, you that whatever was the repo name, you should see a directory, right? For example, in our case, we have the SI 2021. So go into that directory, and what I'm going to do is I'm going to just create a test folder here. So I'll just say make directory, or what I'm going to do is I'm going to just copy uh, the a folder here. So for you, whichever is the top folder where you have all your labs, okay, copy that folder here. So do cp minus rf. So I'm just going to copy the lab9 folder again, just for, let me see, what else do you want to copy? Yeah, I'll just cp minus rf, and then from my home directory, lab, I'm just going to copy lab9 folder and press dot. Okay, so this is just me. For you guys, it'll be different. So you'll see that I have a lab9 folder here. In your case, you should probably have nothing in this folder except for a license if you have done a licensing, and a readme folder, and copy the entire directory. Let's say your top level directory is called lab or VLSI or whatever it is. Just copy that entire directory here. Okay. And then once you're done, do that, do git add that folder name. So in my case, it will be lab9. I'm just going to add that folder. And then you have two more steps. So git is, unlike other repository, you have to first commit. The commit is local, and then you have to push it to the cloud. Okay. Everyone, those of you are still doing the lab copy, just raise your hand. I'll wait. And once you're done, just lower your hand. Okay, looks like everyone is done. So once you do git add your folder name, then do git commit commit, and then give a comment. Otherwise, it'll open VI. Just give some comment like -m space within quotes. You just say added new added lab or something, or just lab. Just doesn't matter. Okay. And then -a, which means that everything will get committed. You don't have to give. You just have one file, but just give it. Okay. Hit. And it'll tell you that in my case, for example, you can see that I had a lab9, I had 3 files in that. All 3 files were created, inserted, showing all the information. So it's still not in the cloud. The last step is you have to do a git push. So if you do a git push, and here you have to give your username and account name, I mean password. So I'll
Sir,
give
he
my,
is asking me, please tell me who you are.
oh, so sorry.
Yes, sir, it's coming.
Everyone is getting that?
Yes,
I mean,
sir.
Yes, sir.
Yes, sir.
what's the error? Just
Sir,
send me a
it's telling
screenshot.
unable to auto-detect email address.
Yeah, just send me that email. Just send me a screenshot. The command is already there, embedded in that. You just have to follow. You remember when I did this in the very first
Okay,
day,
sir. Okay, sir.
I actually updated. So somebody just send me a screenshot because I don't remember the command names. Yeah, so see on the top, it says run git config minus global name user.email, right? So copy that, paste it, and in that uexample.com, just give your email name. Actually, it doesn't matter. You'll just store it for the heck of it. You'll be sending to one, but just give your email address. And then once you have entered that, so let me type it here. So you want to type git space, and this is one time. Once you do it, you don't have to do minus global user.email, and within quotes you give your email, whatever that email is. Okay, so and hit enter. So that will set your email, and then do the next one, git config -- global, just like what it is typed there. Just copy paste, but username and username is not your username of it's just your name. So here I could just type, this is just so that when you're committing and all that, names and emails are maintained on the revision control. So you do that, hit enter, and then you should be able to do commit and push.
So please repeat that email part.
It's saying that you need to set your email. It is given you the command. Just copy git global. Where is it? Oh, I haven't, because I didn't enter it. So just copy and paste it. You guys have that error, right? Git config just it's given you in the error. Just copy paste it. Just put an email address. Put your email address there, right? Whatever is your user at gmail.com or whatever it is, just put it there.
Sir, after putting the email address, I got this. I've sent that in the group, sir.
Config spelling with mistake.
So Sumant, I mean, when are you going to like do something on your own? It is saying config is not a JIT command. The most similar command is config. I mean, you won't even read 5 lines and send it to us, right?
It's clearly mentioned config and config. And
you guys ask for salary. I mean, even if you guys pay me a lot of money, I'm never hiring you. This is insane. I mean, I teach Python to 6th grades, 7th grades. So you should sometimes sit in that course. I mean, the guys are phenomenal. 7th class, 6th class students, I do Python. They're just like, they're just ahead of me all the time. And here it's like there is an error written like just 5 lines, and it is telling you probably wanted to type config, but you typed config, and he won't look at it. Okay, so is everyone done now?
Yes, sir.
So you need to run both the commands, by the way, the username and the email. All right, so once you're done that, do a git push now. And here you give your username, I mean the account name, which is your username, and your password, whatever is your password.
Sir, after commit, we will do git
Yeah,
push.
after commit. Yeah, you have to first do a commit. So you have to add the file, do a commit. So every time you add a new file, you have to do a git add. And every time after that, you're just making changes to the file. You don't have to do add anymore. You just do git commit and push. So here, if you're seeing something like this, that means it's successfully pushed it to the cloud. And if I go, for example, now and refresh this thing, you see this Lab9 folder now, and all the 3 files are here. And then after this, so what you do now, this is what I would suggest. Once you have cloned it, from now on, well, which is just 2 days more, you just work in this folder now. Okay, so that way all your new files and everything will be there. You just keep adding git add commit, and every time you make change, you do the commit and push it, and you'll always be up to date on your GitHub page. And then on Friday, when the lab ends and all these will be terminated, you can just pull it somewhere else. So now after that, you create your virtual box or another Linux machine, or in Windows also you have git git apps, so you can clone it anywhere you want after that and just continue with it. Okay. So those who were trying to clone, they're successful, or anyone stuck, not able to do it? Sumant, now you're able to do it or not?
Sir, after that also I got some errors. Like I have done that global username and email both. After that I did the git push. Uh,
So what's the error now?
SRC, sir, I am sending the photo.
It better be not something. Yeah, just
Sir,
send. Yeah.
so when you're typing the password, it will not show, right?
No, it will not show. But why are you why are you worried? I mean, you're not sharing your screen.
No, sir. I'm sir typing, but nothing is visible in the screen. So
No. Yeah. So when you're typing your password, it'll not show anything. No stars, nothing. It's just happening in the background. That's obviously for security purpose. What do you have in that directory, Sumant?
Sir,
What do you have in the directory?
which
That
directory?
VLSI directory.
Sir, that VLSI directory was my repo name.
What do you have it in that now?
Nothing. Only Lab9. I had only Lab9, which I
So you
created.
have, can you do ls there? Just do a git status and send me the screenshot again.
The JIT status.
Git space status. So like, for example, if I type here, git type status, so it'll tell you which files are needed to be added, which is changed, which needs to be committed, and all that. So just do that and send it to me. I mean, send that screenshot. Okay, you haven't even added it. You haven't added, it's saying you there, it's a new file, which you need to, and there is no commit, there is no added. So why weren't you doing that? So you have to do the add. Wait, I mean, how slow do I have to go? Git add your library name, that lab_9. You have to add that and then do a git commit. Git commit, give some comment name. Okay. New file or whatever. And then hit that and then do a git push after that. So anyone else is stuck or not able to commit it? Okay, I think you can go back can be watch this part, or just do a little search. Now that you have your repo and it is committed there, it's easy to commit it. And once you do push it to your server, you should see your new file. And what I'll suggest is, now you should just work in this file. Okay, don't work in SI 2021-03 VLSI like I have here. That's because this is our repo. You work in your repo, whatever that repo is, Lab9, VLSI, or whatever repo you have created. You just work there and keep updating to the GitHub page. Okay, any questions on either the lab or Git thing we did right now? Any questions on it? Okay, I think I'm going to just end it here. People who weren't able to follow this um, lab here, I would say definitely go watch the video and do it, because it's a really powerful tool at your disposal for free. You can draw schematics, and the beauty about SUE2 is actually very easy to create um, these symbols for any technology. And that netlist you saw is actually written in Tickle. So this was actually written in Tickle. We have written it in Tickle, and you see the symbol. So if you have a new technology and instead of SIMOS N, it's NP, and W is something else, you can write all that and create a new symbol and do all your schematics and simulate it here and so on. Okay, Santanu, I think I'm just going to stop here. Did you want to add anything, or?
No, sir. So tomorrow, sir, day 2 o'clock will.
Yeah. So tomorrow we're going to cover. So I think we pretty much covered everything. The agenda we had. We actually covered a lot of extra stuff, like the logic effort and all that. I decided to cover that. We had a plan to do actually a SRAM project, but I was a little little bit more optimistic. The pace at which we are going, obviously,